Welcome back. Question 14, JAM 2023 past question, physics. Now, consider this circuit given above. Now, let's see question given under it. They said in the given circuit, what is the ammeter reading given that the voltage across the capacitor and the inductor are 300 volts each. Now, looking at this circuit, we can see that it is an AC circuit. What kind of AC circuit is this? It is a RLC circuit. How? Because it contains resistor, inductor, and capacitor. So in that case, we call it RLC circuit. Now, these three components are connected in series. So we call it RLC series circuit. Now, the resistor is 100 ohms, while the inductor is 5 millihenry, and the capacitor is 10 microfarad. Now, the question is asking for the ammeter reading. Ammeter reading simply stands for the current flowing in the circuit, the current flowing through the component in the circuit. How do we know? The same current, first of all, the same current flows through all of them because they are connected in series. Now, the total voltage of the circuit is given as 220 volts and frequency is given as 50 hertz. This is what is coming from the mains. Now, from here, if we are able, since we are given the voltage, the potential difference across this and the potential difference across this, and we know the effective potential difference, we can use these three to get the potential difference of this, because this one alone can be used to calculate the current flowing in the circuit, since the same current flows through all of them. So if we are able to use this only, we can get the current flowing in the circuit. Now, how do we go about calculating the potential difference flowing across the resistor? Now, we are going to use the formula of total PD. That's V equal to square root of VL minus VC squared plus VR squared. Now, in a circuit that contains R, L, and C, that's resistor, inductor, and capacitor. This is the formula for calculating the effective effective potential difference, effective voltage, or effective PD. Now, we can get that from here. See, the V is 220 volts equal to square root of VL from here is giving us 300 volts. 300 minus VC is also 300. Take the square of that plus VR, which is the one that we are finding. That's the potential difference flowing across the resistor. Now, from here, 220 volts equal to this minus this will give me 0, of course. This is 0 squared plus VR squared, which is the unknown. That's the potential difference flowing across the resistor. Now, this is equal to 0. 220 equal to square root of VR squared, because 0 plus anything is that thing. This cancels this. That means we have VR. That means VR is also equal to 220 volts. So that means the voltage flowing across the 100 ohms resistor is also the same as the total voltage of the circuit. Now, from here, we can now use our Ohm's law. Ohm's law, which says that V is equal to IR. So we can use it to get our current. So in order to get the current flowing through this, we can rewrite this as VR equal to IR. Let me make I the subject of formula. I will be equal to VR all over R. Now, what is VR from here? That's 220 volts all over R. That's 100 volts. 0 cancels 0. That's 2.2 ampere. So, looking at the option, we can see that option B satisfy our answer. Thank you for viewing this. God bless you.